Hello. Hopefully you're well. I'm gonna go ahead and do 2.6. It's really short and sweet. So I'm gonna just go ahead and go through it and then I will upload the answers to 2.6 so that if you want to work on it, you'll have it. So I'm going to share. All right, so keep in mind that you are responsible for this information for the test. So I'm going to go ahead and read, and then we're going to have a real quick discussion. So it says a quadratic and exponential curve can look similar. So if you think about it, a quadratic curve looks like this, and then the exponential curve kind of looks like this, right? So it looks like it's going to curve or make a U shape. So how can you tell if a quadratic model or exponential model will be the better fit for a data set? For students who are, if you're familiar with statistics, you have R and R squared, and the closer it is to one, the better your data set is. But you'll do more with that if you decide that you want to take statistics next year. But we're going to keep it simple. We're going to look for context clues, right? Is something growing at a constant rate? Is it growing at a linear rate of change? Is it growing at a proportional rate of change? So these are things you already know, and you're able to kind of look at that and kind of make a guesstimation or educated guess. So it says a pizza, for number one, a pizza is removed from the oven, cools down for 5 minutes. During this time interval, the temperature is recorded once every 10 seconds. The recorded temperature with respect to time can be modeled by linear, quadratic, or exponential functions. For each of these models, they appear to represent the data. Which of the following conclusions can you is best? So if we're thinking about this, if you're taking physics, you're learning or you will learn about Newton's law of cooling. And what his law says is that if you have something in the oven and you take it out of the oven, it will continue to cool until it hits room temperature. So if your house or the room that the cake is in, let's say you're baking a cake, in this case, we're baking a pizza, if the room temperature is 75, it will cool from 400 degrees all the way down to 75. So the model for that will look like an exponential function. So our answer for this first one, it says, which one is the best fit? Your answer is C. An exponential model is the best based on context clues and what we know about Newton's law of physics. All right, or sorry, Newton's law of cooling. So another very useful way to know if a model is appropriate for a data set is to look at the plots of the residuals. So we did residuals. I did a video about residuals a few weeks back, and we talked about what a residual or how to get a residual, right? So what is a residual plot? Recall that regression lines are lines of curves that fit the data set. So a residual value is how much the regression curve vertically misses a data point, right? So you take the actual measured value, measure data points, and subtract the predicted value from the regression. When you do that, you get the residual. All right, so actual minus predicted is residual. We're not going to spend a lot of time on that today. Our focus today is going to be on what I'm going to talk about next. So I'm going to move. And so it says this gives us a new set of data points that can be graphed as a residual plot. The difference between the predicted and actual values is in the model is what we call an error. So I'm going to put in here error. Let me make this smaller. Right. So the difference between the predicted and actual values is what we call an error. And if you're looking at this line here or this data set, this is your best fit line. Let me make a better line. I'm just going to use the line tool so that it looks better. And I'm going to use a color we can see. So let's use blue. All right, so this is a line of fit, right? So the closer you are to that line, the better your data is. So obviously this point right here is way off, right? It's an overestimate, what we call an overestimate. The lines down here, or these points down here, this point right here is an underestimate, right? But this is kind of like, okay, this is our line of fit. This is the best we can get based on the calculator. So how do we predict it? It's kind of like the opposite of what we did before. Predicted value minus the actual value will give you the error. The error. So before, if you want to come up with an acronym, we had the AP, APR, so actual minus predicted gives me the residual. And then PAE, predicted minus actual gives me the error. So notice that a residual and an error are very similar and often used synonymously, but there is a difference. The sign of the error tells us if the prediction is an overestimate or underestimate, whereas the residual that does not do that. So let's look at an example. It says a high school student is getting ready for basketball season by getting extra practice before school. Each morning he records the number of practice shots he took and records how many he made. The table below represents his recordings. So I'm going to do this in Desmos. So I'm going to share my Desmos screen. And then I'm going to show you how you can do this when you're at home. So we're going to click on the plus sign. We're going to click on table. We're going to put in our data set. So 100, enter, 75, 120, 200, 50, 300. And then for my Y1, I'm putting in the shots that he made, which is our output, 35, 22, 37, 60, 20, and 126. So make sure that all of your data is put in there correctly. So once you get here and you have everything in, you're going to click on this here. And the first question says, what is the regression curve, right? So I have this value. I'm going to just grab a photo of it and then put it into my data or into my slide. Right, so I'm putting that into my slide. You can simplify it to 3 decimal places, and I'll show what that looks like when I go back to the slide. The second question is asking you to evaluate your using your regression line. And it says use your model from part A to find the error at t = 50. So what I did is I'm going to click on this equation here, and it's going to bounce it to the next or the second row. And then instead of X, I'm going to put a 50 in here for X. And then it gives me this answer. So again, I'm going to grab another picture of that, and then we're going to go back to the slide so we can have a discussion about what all of this means. So real quick picture. All right, so, and then I'm going to share my screen. So for the regression line, if you can either write the whole thing or you can write it as y equals 0.417 x minus 8.701. And same thing for the error model here. We ended up with 12.139. I'm going to simplify that to 12.149. And I'm rounding. That should be 140, sorry. And then when I'm plugging and chugging, it says use your model part A to find the error. This is the error. I'm sorry, this is what we plugged in for 50. So I'm going to do the predicted minus the actual, and that will give me the error. So the predicted amount is the amount that we got in the calculator minus the actual value at 50, which is 20. And then when I plug that into the calculator, I don't know why I keep putting a 9 there. So 1.12.140 minus 20 gives me a negative 7.86. And so for the next question, it's asking, is the value predicted an overestimate or an underestimate? So the actual value was 20. We ended up with 12. So this is an underestimate, right? So I'm going to type that in here. The predicted value of 12.140 is an underestimate of the actual value of 20. All right, so any questions here? We can talk about it when I see you next class. All right, so let's move forward. So this question right here is asking you, saying several cars were tested for their braking distance. A regression model was calculated with the car's weight in pounds as input values and the braking distance in feet as the output values. The given residual plot has a point labeled P at the coordinate 3,300 and then negative 15. So what does point P indicate in context? So if I'm looking here, remember this line right here is my regression line, right? And then this is my model, and I'm only concerned about this P. So looking at this P, they tell me that this P is the X is 3,300 and the Y is negative 15. So they want me to say in words what is happening here. So point P is below, right? So the x-axis or below this line here. So we know that that is going to be the line of regression line is an overestimate of the actual value here. So how do we put that into words? I'm going to say because P is below the x, because point P is below the x-axis, or we can say regression line. For the car that weighs 3,300 pounds, the model overestimates the actual braking distance by 15 feet. Spell braking wrong. Again, this is wordy. You can change the wording a little bit to say that P is below the regression line. So based on this regression line, the weight of the car, a 3,300 pound car, this model right here overestimates the braking distance of 15 feet. All right, so we're going to move it on to the next question. So residual patterns, there are different types of patterns. It says, how does the shape of the residual plot tell us if the regression curve is an appropriate model for the data? One way is to ask the question, do the residuals exhibit a clear pattern? In a good residual plot, The residuals exhibit no clear pattern. So no pattern is a good regression because you can't really look at it and see what's happening. But the calculator can pull it and give you an equation. In a bad residual plot, the residuals exhibit some type of pattern, such as a curve or a wave. But a pattern, it means that the regression model is bad. So as you can see here, we can look at some of the patterns we're looking at here. This kind of looks like a parabola. This kind of looks like a linear function. And this one has two linear functions. So it could be a piecewise function or something weird going on like that, right? And then if you can see, notice that the line here is below for all three of them. And then here, the data is kind of around the line. All right. So I am going to upload the practice answers. Again, you can use Desmos to help you plot. If you have questions, you'll see me next class. Take care. Bye.